Right. So let's start with section 6.7 today. In this section, now that we've learned how to work with radicals and nth roots and so on, we're now going to take a look at how to solve radical equations. Okay? So the first thing you want to do when you're solving radical equations is you want to isolate the radical on one side of the equation. All right? And it's best to try to have just one radical on either side. Then you have to raise each side of the equation to the power equal to the root to get rid of the radical. You have to solve, and then we have to check for extraneous solutions. So let's go ahead and get started here. So the first step is to isolate that radical. That means I need to bring everything else to the other side. So I'm going to start by adding 1, and that gives me the square root of y minus 1 equal to 6. Now, this is a square root, right? You have to look here at what that number is. And so we know that this is a square root. That means that index is technically 2, right? So I have to raise it to that same power. If it was a cube root, you would raise it to the power of what? 3. Okay, so now the square and the square root make each other go away. So I have y minus 1 equal to 36. Add 1 to both sides. Y equals 37. Now, when we were graphing square roots, right? Remember the square for a graph, the graph for a square root looks like this, right? So remember there's a whole bunch here that is not in the domain, right? Because what is the one condition always? That whatever the radical is, if it's an even root, underneath the even root, you can only have 0 or a positive number, right? So for even roots, you have to check for extraneous solution. This we said was a square root. That little index is a 2. So when it's an even number, 2, 4, 6, 8, you have to check to see if your answer works. To check, you can plug it into any step before you did the initial squaring. So for example, you can plug it into the original, or you can plug it here before you square. Why don't we try in the original? In the original, I put in the square root of 37 minus 1. Minus 1, is this equal to 5? So here I have root 36 minus 1. This is 6 minus 1. That is equal to 5. So this answer is okay. All right, questions? Okay, now take a look at this one. I have one root here, one root there. I have 2 roots, right? No matter what, I can't get one root alone, which is fine. But what I want to do is I want to make sure the roots are divided so that I only have one square root on either side of the equation. Yes?
Will you be able to combine the roots?
No. So what I'm going to do is the following. I'm going to square this side, and I'm going to square the entire side over there. Now, here, this becomes x minus 12. That's pretty easy. But here, I have a binomial, 2 terms inside that parenthesis that are being squared. So remember when we have that, we have to write it out like this and FOIL it. You guys remember that? Okay, that was from like the beginning chapters as well, and in this chapter. So x minus 12 equals, all right, so let's do this. First terms, 4. Outer terms, 2 times negative root x, negative 2 root x. Inner terms, what does that give you? Also negative 2 root x. Outer terms, okay, first of all, hang on. It's negative times negative, so it's going to be positive. And then we have root x times root x That's just x. Okay, so now let's see what we get here. X minus 12 is equal to 4. This will give me negative 2 root x, negative 2 root x minus 4 root x plus x. Okay, I still have a root, so I have to do this process again. Now what I'm going to do is leave the, make sure to make the root alone. So subtract 4, and I'm going to subtract x. So I get negative 16 equal to negative 4 root x.
Wait,
Now,
what? So you subtract x by x.
hang on, no, I got this. So negative x, right?
Yeah.
And then, so those go away. And then I'm also subtracting minus 4 to make this. Okay. Now, I'm going to divide both sides by negative 4. So 4 equals root x. Now, squaring both sides. 16 equals x. Okay, but now we have to check, correct? So let's do that. All right, so we're going to plug it into the original. Okay, so I have the square root of 16 minus 12 equal to, okay, question mark, 2 minus root 16. So here I have root 4. 2 minus 4 is 2 equal to negative 2? It's not. So all that work, this doesn't even work. The answer here is no solution. Okay?
So annoying.
This other one here, I have something to the power of 1/3. When I write that as a root, what does it look like? It's a cube root, right? This is a cube root. Okay. So, again, you subtract 1 because you want to make that alone here. Now, if it's a cube root, we should raise it to the power of what? 3. If it's to the power of 1/3, that's the same. Basically, what you have to do is you have to raise it to the power that's the reciprocal of the fraction. So do you see either way, it's to the power of 3? Okay. So here I get 3n plus 2 equal to, how much do I get on the right side? Negative 1. Okay, minus 2, 3n equal to negative 3. N is equal to negative 1. Now, this is a cube root. I just told you guys before that when you had an even root, you have to check for extraneous solutions. If it's an odd root, if it's, if it's a cube root, if it's a 3, 5, 7 here, you don't have to check because it doesn't matter. If it's a cube root, you can have positive, negative, or 0 in here. There are no restrictions, okay? So you don't need to check, okay? So no need to check for odd root. All right? So you just get your answer and that's it. Okay, here. I'm going to add 2 to both sides. Now what am I going to do?
You have to do it to 3.
Not yet. Divide by 3.
Oh, yeah.
So 5y minus 1 to the power of 1/3 is equal to 2/3 to the power of 3 to the power of 3. 5y minus 1 is equal to 2 to the power of 3 is 8. 3 to the power of 3 is 27. No. Now, I'm going to add 1 to both sides. Okay, so go ahead and plug that in your calculator. What do you get? 8/27 plus 1.
35 over 27.
35 over 27. Hang on. Now, divide by 5, which is the same as multiply by 1 over 5. So y is, these actually cancel. You get 7 over 27. Thank God there is no need to check. We're done. Okay. Okay, so what do we do first here? Subtract the 4. Okay, is this one where we have to check? Yes. Okay, guys, I need participation from more than one person, please. Otherwise, I'm going to have to call on you guys. Root 3x minus 6 is equal to 3. All right. This is a square root. It's a 2 inside, so I'm going to square both sides. 3x minus 6 is equal to 9. Okay, now this becomes like, an equation from chapter 1. To get x alone, add 6, add 6. 3x equals 15. Right. X equals 5. So now let's check. This time, I'm going to plug it in to this step here before I squared. So let's see. The square root of 3 times 5 minus 6, is this equal to 3? 15 minus 6. This is root 9. That is equal to 3, so this is a solution. All right? Okay, next. Go ahead and do the next one on your own. I'll give you a couple minutes. Maybe I'll even like race with you. Okay. Right. So remember to always check with these because, right? I mean, we did just get one with no solution, right? Okay. So here, what do you guys suggest we do? Josh.
You have to distribute the negative first.
No, we can't. That's actually illegal. Josh, what do you think? Move one to the other side. Okay. Remember, anything inside a root is everything that is inside a root, like they're in jail, right?
Oh, right.
And this negative is outside of jail, and you can't associate with people that are in. Okay, so we're gonna move. We're gonna add, because it's minus square root of 9 plus x, we're gonna add it to the other side. So 2x plus 5 in a root is equal to this. Square, square. Okay, so 2x plus 5 equals 9 plus x minus x from both sides. X plus 5 equal to 9. X is equal to 4. Maybe. Let's check. I'm going to again plug it into this step. Oops.
Wait. No. How would it be?
And then I'm going to plug it into here. Yeah, go.
Oh, because it's minus.
Okay, so let's check. So here, in the square root, I have 2 times 4 plus 5. Is this equal to 4 plus 5? So what is this? 8 plus 5 root. Oh, no, sorry. This is 9 plus 5. Okay, so in this parenthesis, I have root 13. My words. Oh my God, I wrote all the numbers in there wrong. Okay. So 8 plus 5, that's root 13. And here, root 13, that does work. So, right? So even though Mrs. Malikian, right, was doing it wrong, the math, right? The math, you see that? If right. Okay. So the math of it was right. So that's that. And the book, there's book homework from this.